Okay, we understood what is Spark in our previous class. Move forward to understand the Spark in bit more detail. Let us understand the Spark architecture as a part of this class. First and foremost thing is, let me ask a question to Anna. If you have a PC, one PC or one laptop, what and all you can do with that?
So I can do tasks like coding or
Okay, very good. What and all you can do, Malini, with one PC?
Browse.
Browse. Okay. Vinith?
We can do a lot of things, but we cannot do them on a very large scale. Like
You are hitting the right point. Okay. Yeah, that what you are saying is right, Vinith. Okay. But have anybody watched a movie on a PC or a laptop in this group?
Yes, sir.
Right? I mean, nobody said that. You can say that. Okay.
yes, sir, I have said yes.
Is it okay? So when you have one system, you can watch movies. I have literally watched lot of movies on my laptop. Okay, and do some analysis in Excel, and we can install the applications. Okay, and work on those applications. So let me ask a question to Muthuminal. What we cannot do in one system, one single system, Muthuminal?
We cannot handle large amount of data.
Okay, good. Any?
Can to store means we need to store another system like
Very good.
photos,
Very good.
images, Excels, everything.
Correct.
And we
Okay.
need to record means we need to little bit only we can record that. Anything.
Okay. Got you. So what we cannot do is we cannot perform the data processing of the huge data as said by Vinith and Muthuminal. Okay. Then what is the solution, Malin?
Adding one more PC for storage.
Yeah. Very simple. Very simple. Thank you for that. Okay. So instead of having one system, we all already know we can have more systems connected over a network. Right? With this, we can do data processing of huge amount of data. Sharanya, is that enough? Just adding the systems, is that enough?
Might be no sense.
Yeah. Vinith, what do you think? Is that enough? By mere
Sometimes we need real-time processing and real-time results, so it's not enough.
then what do you need? What do you need?
The streaming of data,
Okay.
real-time processing.
Okay. Anybody?
In this kind of structure, I think the batch processing kind of thing will happen, but
Mhm.
streaming kind of thing.
Okay. So my
All the
question,
systems should be
yeah.
connected internally with the same network.
See, we have a systems connected to the network, but by mere systems will not have work, right? We need to have a framework. Along with these systems, we need to have a framework which will analyze the large amount of data. And which is that framework? Which can analyze the large amount of data in a distributed manner? Which is that framework?
Hadoop.
Hadoop. Okay. Any other framework? Any other?
Spark.
Yes, you guys are in a Spark. Okay, that is Apache Spark. Okay. So we already know what is Spark. I'm trying to say the Spark is a framework or a platform or a unified computing engine to perform the huge data processing in a parallel way. That is one more way of looking at Spark. Okay. The way Spark achieves that by having this particular architecture. Okay. We have something called driver process. Okay. And we have something called cluster manager. Driver process and cluster manager. And we do have something called executors. So these three important components of a Spark communicate to each other in a two-way communication. Okay. If you see here, the cluster manager does talk to the driver process in a two-way. Okay. Anybody like Vinit, does it in your home? It is a two-way communication or it's a one-way communication?
It's two-way communication all the time, sir.
All the times. Okay. Kabhi, whenever somebody is angry, whether you are angry, your wife is angry, then it is one-way communication, right? Okay. How about you, Parveen? One-way communication, two-way communication?
Two-way, sir. Two-way
Two-way.
communication.
Two-way. Whenever there is angry, it will be one way. Okay.
No, yeah, in that
Uh,
case, one way only.
And that period will long last, or it will be only for some time?
Sometimes, sir.
Sometime. Okay. It happens in all the homes. Okay. So, okay. I mean, don't go to your previous one-way communication stage. Okay. Always let us hope there'll be always two-way communication in all our families. Okay. And luckily, we are having a two-way communication in our classes also, right? Which is good, right? Instead of having
Yeah.
only one way, it is a two-way communication. Okay.
Yes,
That way,
yes.
it is interesting.
Yes.
See, two-way communication is always good. Always good. Whether it is in a class or a family or a friendship or anything. Okay. So, two-way communication is good in Spark as well. Okay. So, here,
Yes.
cluster manager talks to driver process, and in turn, driver process communicates with the cluster manager. And executors talk to cluster manager talk to executors. The same is the case between driver process and executors. Okay. So three important components: driver process, executors, and cluster manager. Okay. Let us understand them one by one. Okay. What is driver process? Anyone, based on what you know?
Where code is written?
What is written? Okay.
Sir, initial processing of the
Mhm.
session,
Okay.
the process that initiates the process.
Very good, very good, very good thought process. Where are you getting today? Vinit seems to be in a farm. So I think you had a very wonderful blasting weekend, I guess. You had a
Sir, everything is written on the screen. Driver
where is it? Okay, driver
Okay.
process. But okay.
Actually, what is driver, sir? Driver drives the starts
Ah.
the car first, then he will drive.
Very
na?
good. That is a very good analogy. Very good analogy. Okay. Yes. You are right. Okay. So driver process runs your main function, and it is responsible for three important things. First and foremost thing is it maintains the information about the Spark application. So if I ask you a question, Anna, Spark application, what is Spark application? Anna is thinking. Anybody wants to give a try?
It is a framework
Okay. So please listen to me. Okay. Here, let us say, for what reason you are using a Spark for?
for parallel processing, sir.
For parallel processing of what?
Data.
Yes. Okay. You are using the Spark to parallelly process the data. Now, this you are doing by Spark, right? In order to do that, you have to write a code in Spark, right? So, that series of code to perform a parallel processing of a data in a particular project is a Spark application. You got it, Malini? The series of Spark code to parallelly process the data in a particular project, a project which you are involved in, Malini, project which Anna is involved. Maybe they are two different projects, right?
So this is the front end of the Spark, you mean to say?
No, basically, let us say you have in a retail company. Okay, Mintra. Okay, so in Mintra, you have a project to perform the parallel data processing to derive some insights. Okay, so for that, you write some 1,000 lines of Spark code, right? I'm just taking an example. So this whole Spark code together becomes a Spark application. Okay, it is when I say don't go by when I say application, I know where you are coming from, Malini. Okay, application means it's kind of a front end. So here it is not. I mean, the whole code written for parallel processing is called as the Spark application. Now, driver process is the one which maintains the information about the Spark application. Okay. And the next thing is, whenever user want to interact with the Spark, the driver process is the one which responds to the user's program or input. Like you and me, we are the programmers which interact with the Spark. So driver process, what is driver process, by the way? Is it a one more component? Is it a one more Spark, or is it a component of a Spark? What is driver process, by the way? Anybody?
Maybe it is a component of Spark.
Not maybe. It is a component of a Spark. That's what I discussed, right? So in as a part of the Spark architecture, we are discussing this driver process. Okay. So Spark architecture has driver process, cluster manager, and executors. So we are drilling down on driver process now. So driver process is the main component which is responsible for three things. First and foremost thing is, it maintains the information about the Spark application, right? Whether it is opening or is it running, or what kind of activities happening in the Spark application. And the second thing is, it is responsible for responding to the user program. Okay, user program means you may write, let us say Anna may write a program and submit it to the Spark for some reason. Okay, it will respond. Driver process component is the component of a Spark which will respond to the user's program. And the last, which is very, very important, is it is responsible for analyzing, distributing, and scheduling the work across the executor. This is the core of the driver process, because your data is spread across the different systems in a cluster. Now, in order to process the data, you need to analyze, distribute, and schedule the across the executors. As it is performing so important functions, it is called as lubdub of Spark. What is lubdub?
Heartbeat.
Heartbeat. Okay. Heartbeat is from heart only, right? Okay.
Yeah.
Okay. So since it is absolutely essential, it is performing the important aspects of the Spark, it is called as a heart of a Spark. Okay. It is called as heart of a Spark. Okay. So hopefully, I mean, all of us except, okay. So all of us already have given a heart except I think Muskan and Jaypal. Okay. Right. So Vineet, have you given heart already, or you are yet to give heart?
See this on my screen. Heart is
Heart is already given. Okay. So it is called as the heart of a Spark application. Any questions here? No questions. Have you guys started
What are
thinking about?
executors?
We'll come to that. Okay. Now we are going one by one, right, Malini? We completed the driver. No, I know why you are asking is because I am saying it distributes the work across the executor. That is the reason you are asking, right?
Correct.
Yeah, I got it. I am reading your mind already. Okay. So we completed the driver process. Let us understand the executors. Okay. See how I am reading mind of everybody. Executors are nothing but component of the Spark which are there in the nodes of the cluster, which are responsible for executing the code assigned by the driver. It is basically, let us say, you have a system. Okay. So these systems are connected, right? Now you have a driver process in one system, okay, which will assigns the codes for this. Okay, there is a executor 1 here, executor 2, executor 3. Okay, I'm just taking a, okay, you have data part 1, data part 2, data part 3. So data is already distributed. Okay, now when you install the Spark, okay, you have a driver process and our executors are there in all the different nodes. Okay, now so driver process, what it does is it distributes the work to the different executors which are there in the different systems in a cluster. Okay. So executors are the ones, they are the ones which will execute the code assigned by the driver, and they report the results. Let us say it will execute it to processes the data of DP2, and it relays back the results to the driver. Okay, got it, Malini?
So even the libraries are on driver process only. On
Yeah.
the driver,
Yeah. Yes.
Okay, only execution happens on the rest of the system. Okay.
Correct. Executors are there in the different systems of a cluster. Okay. Executors are from the Spark side. That is a component of the Spark, right? If you guys draw the analogy of MapReduce, mappers will be there in the different systems, right? Mappers, which will process the data, part of the data. In the same way, we need something from the Spark, right? Those are the executors. They're not exactly same. I'm just trying to see if I can make you understand by drawing some analogy. Okay? Got it, Anna, Parveen? Okay. Now,
Yes, sir.
the last one is the cluster manager. Any idea, Parveen? What does cluster manager do?
Managing the clusters, sir.
What does it mean? Yeah, that is a very smart answer, by the way. But what does it mean?
Component of Hadoop.
Very good. Very good.
Spark is not directly sit on Hadoop.
Mhm,
So
mhm.
Yarn is a I think, sir, Yarn is like a mediator between Spark and the HDFS, I think.
Okay.
So sorry for the confusion.
No problem. That's okay. See, one more very, very important thing, guys. When I ask a question, without even teaching you, what I'm trying to do is I'm trying to invoke some trust. I'm trying to make you think, right? I mean, I have not yet thought, but what is happening is based on what I have already thought earlier, you are trying to like give some answers. Sometimes it is true, sometimes it is not true. Whenever it is not true, what will happen is you already thought something, you will correct yourself, right? That is what is happening here. Okay. So, and
Yes.
also one more very, very important thing is instead of preparing you for the interview after course is done, in a way I'm preparing you for the interview now only. So that
Yeah,
is what
yeah.
is happening here. Okay. So I told you these are systems. In systems, the data is distributed. Spark is also installed in a cluster, and Spark driver process is one system, and all the other executors are there in the different systems. But we already understood when we dissected the definition, Spark is a computing engine. So Spark only focuses on processing the data, but there should be someone to manage the physical resources, right? Anna, what does it mean, physical resources?
So the components like
When I say physical resources, what am I referring to here?
Notes,
Anyway,
sir.
yes, absolutely. Node means what?
CPU and disk, sir.
Absolutely. Bingo. Yeah, really you are in farm today. Yeah. Okay. CPU and disk. The reason is we are not analyzing one file. We are not storing one file. We are storing multiple files. How do you know this system has only so much of capacity? Somebody has to monitor that, right? That will be done by the cluster manager. When I say managing the physical resources, I'm talking about the CPU, memory, disk space, and all those things. You got it now, Parveen? Got it now, Anna? Okay.
Yes, sir.
And it is the one which allocates the resources. It is the one which allocates the resources to the executors. Okay. Wonderful then. That is a Spark architecture in a nutshell. Okay. Again, are you going to work on a Spark architecture on a daily basis? No, you will not. But you need to understand how it works. Okay. So, any questions here before we move to the next topic? One more thing what I covered earlier, Spark supports the multiple languages. In order to make that happen, Spark has something called language APIs. Means Spark is an application. When I say application, Spark is a one computing engine, right? Now, in order for the Spark to support the languages Python or Scala or Java, these two are not same. You need to have they have to interact through APIs to make sure that Spark can support the different languages. So what happens is between the Spark and the different languages, there is some kind of a mapping. Okay. So Spark maintains something called concepts in every language. Means, let us say I have a Python, I write some code. Okay. That code is in a way mapped to Spark code. Okay. So whenever you write a code in Python, there is a kind of a mapping between the Python code and the Spark code, which we call it as a core concepts in every language. Then that code is translated into the Spark code. So at the end of the day, Spark code is the one which runs on the different clusters in the machines for performing the data processing. Okay, that is how Spark is able to support the multiple languages. Okay, because it has a API for these languages. In order to support the languages, Spark maintains something called core concepts for each of the language. Whenever you write a code in some other language, that is translated into the Spark code. Spark code is the one which will go to all the machines in a cluster and performs the data processing. Okay. If you are able to absorb this, to absorb it, otherwise it's okay. Okay. So I don't think anybody will ask you about this in interview, according to. Okay. So now, as I said, Spark supports different languages through APIs. First and foremost thing is Scala is a default language of a Spark because Spark itself is written in Scala. Any questions? I mean, are you guys able to get it at a high level? Okay. Spark is written in Scala. Okay. And then we have a Java. So you may argue, hey, since Scala is there, Python is there, why do we need Java? Because at the time of the Spark being written or the Spark being like developed, Java used to be one of the core language. And now also, I would say 50 to 60% of the applications worldwide are still written and maintained, are basically developed and maintained in Java. Does anybody differ from me? Are you guys able to understand what I'm trying to say, right? So since lot of applications were developed and maintained by Java, creators of the Spark went ahead and gave a support for the Java as well. Okay? And then comes the Python. So Python, especially in the data, is ubiquitous. The reason I say that is, if you want to perform the data engineering, you can use Python. For analytics, you can use Python. For data science, you can use. For DL, ML, for all the things you can use the Python. That is the reason creators of the Spark gave a language API to support the Python as well. Okay. Then comes SQL. When we talk about the data from a very long time, that right from the days of who is the one who wrote a white paper on RDBMS? Edgar F. Card, right? Edgar F. Card, EF Card. Okay. From those days, who is working in the data, they usually use the SQL, right? They usually use the SQL. By looking at that, the creators of the Spark even gave a support to SQL as well. Okay. And the last one is R. So what used to happen is, so the Spark is the product which came out of academics from in a University, UC, University of California, Berkeley. It is in the west coast of US. Very good university. It has produced multiple patents and very good technology university. So whenever you develop something from the university, especially for the data processing, now also in the universities they use R language extensively. Okay, because R used to be R is a product which came out of the university. They supported the R language also. However, in the project it is mostly Python, Scala, or Java. Okay, which are the three? Obviously SQL. SQL is the main thing. Okay, I mean R is I have not used R is extensive in the projects in corporates. Okay, it's mostly for the academic purposes. Okay, any questions here? Basically, I am telling you how these 5 languages are supported by using a API in Spark. Okay, any questions here from anyone? Malini, Anna, Parveen, you guys are getting it?
Yes, sir.
Okay. So there is something called Spark session. Okay, is a part of the driver process. Okay, if you recollect, what are the important aspects of the driver process? What and all it does, Parveen?
Sir, it is going to run our main function,
Very good.
maintaining the information about the Spark application
Awesome. Very good.
to the inputs or user program.
Very good. The last one.
Distributing and scheduling across the executors.
Very good. Awesome. Okay. You covered all of them. Okay. So that means that, and also this is a lub-dub of Spark.
Hearts are hard.
Heart. Okay. Now that we understood that driver process is the heart of the Spark application, it does multiple things. Let us understand what Spark session does. Okay. In a way, Spark session supports all those 3 of them. Okay. So Spark session is the way Spark executes the user-defined manipulations across the cluster. Okay. So whenever you write something as a part of a Spark application, that will go through Spark. That will go through Spark session. Okay. Spark application, if you guys remember, it is a code written by a user in order to perform the data processing. Okay. So if that code has to be executed, that will go through Spark session. Okay. In a way, what happens is it acts as a gate for the user's code. Anything has to go through Spark session. So in a way, it is a gate. It is the entry point for the Spark application. Okay, that is a Spark session. So now Spark session is available in 2 ways. Okay, whenever you are using a interactive mode, Spark session is implicitly available. But whenever you are using a IDEs like Jupyter Notebook or PyCharm, right? You need to create the Spark session yourself. Okay. In the interactive mode, the Spark session is available implicitly. In the standalone application mode, where we develop the Spark application by using IDEs, you have to create the Spark session on yourself. Okay. But whenever you work in something called Databricks and all those things where you invoke the Spark, there it is implicitly available again. Okay. We'll see how does this work in practical tomorrow. Okay. Any questions here on what are we covered so far?
No, sir.
No questions? Wonderful then. If there are no questions, we'll wrap up the class for today.